Hello friends, welcome to Code Sutra. In this video, we'll be solving Leetcode problem number 1325, delete lace with a given value. It's a very simple but a very beautiful problem. This will actually blow your mind, right? So in this problem, we are given a binary tree or the root of a binary tree, and also we are given a value. So for example, this is the value. So what do we have to do? If any leaf node is having this value too, so we have to delete this. So what happens when we delete this? So this will be the result, right? So this is the expected output. We deleted the leaf node with the value 2 and the remaining tree remains the same. Now there is a catch here. So what is the catch? Let's take this example, right? Let's go very deeply. Now what happens? We will delete this too because that is a leaf node. Now again we will delete this. And what is the result now? If you see, it will be 1, 2, then again 2 here, and there will be 4. But the catch here is, now since this is the leaf node, you have to delete this as well. So what is the expected answer? The expected answer is just 1, 2, and 4. Now, see, you are not deleting this 2. Why? Because that is not the leaf node. So you will be deleting the leaf nodes. And if at all, after deleting the leaf nodes, if there is a leaf node with this value, we'll be deleting that as well. Now let's look at the solution. Now before looking at solution, if you are approaching any problem, just think in this way. How did you solve this problem on the sheet of paper, right? So if you look at this, how did you start? You did not even look at the root node, right? So all you did was you started from the bottom, right? You saw this value and you deleted this value, then again you saw this value and you deleted. So then once these are deleted, only then you go to the next layer, right? So what did we do here? We first visited the child nodes. So this is also called as post order traversal. There are three kinds of traversal. One is in order, another one is pre-order, and the other one is post order. You can actually research about this, but the one that we are using is post order. Just like the name implements, what does post order mean? Post order means we will visit the left node, then the right node. That is basically we will be visiting the children nodes first, and we will do the operation on them first, and we will then come to the root node. So what are we doing here essentially? So basically this is what we did, right? So here we are. So you are standing here. And what do you have to do? You don't have to process this node. You go to the children. So you go to this node and you say, I have a left child. You process this and give it to me, right? So you go to this node. You are standing here now. Then again, does this have a left child? Yes, it has a left child. So you come here and you say process and give it. So what does the process mean? Since this doesn't have a left or a right child, it is the leaf node and the value is also equal. So what do? You just delete this. Right. So now what will be the result? 1, 2, and this will be a null. Right. So this will be the result. Now again you go to the right child and do the same thing. Now give me the result. So this will once again become null. Right. So then on this node, again it doesn't have a left child or a right child. Then this again becomes the root node and you will be deleting this node. The same thing happens here, but you go here, it doesn't give a null value. So it gives you the actual node. Now is this a leaf node? How do you check if it is a leaf node? You check if the left child and the right child are equal to null. If they are null, that is the leaf node. If they are not null, it is not the leaf node. So since this is not the leaf node, you need not check. Now let's dive into the pseudocode of this problem. It's very simple. Just like we mentioned, what did we do? We first went to the left child, and we saw you do the operation on my left and you give me the left child. Similarly, you do the operation on the right side and you give me that, and I will store it as my right node, right? So, and the final processing is here. We will be checking if that is the leaf node or not. How do we check if it is leaf? If it is equal to null, if the left node and the right node are equal to null, that is it doesn't have any child, and the value is also equal to t. In that case, we'll be removing the leaf node, right? And if at all, if the root equals null, we'll be returning that value. Thank you for watching the video. Please do like, share, and subscribe.